Aloha, Richard Halverson here. This is ITS128, and today is October 14th, Monday, and we're starting week. Let me open up and see where we are. We are in, this is week 8, and we're doing chapter 5, starting chapter 5. And so if we look at these are the learning outcomes, read chapter 5, and complete these 3 quizzes. So in this video, I'm going to cover the 3 quizzes, and I will, and then after this video, I'll make another video probably tomorrow covering the projects. There's 6 projects in this chapter this time. So let's. I've opened up Pearson Revel. I've opened up Revel. We're on chapter 5 here, and we're covering loops, while loops and for loops. And let's open this up. Here, this gives us an introduction. Let's say we want to print something. For example, programming is fun. Say we want to print it 100 times. We can just create this while loop here, and we have a counter, and we have this counter here, and while the count variable is less than 100, it prints this out, and then it increments the count by 1, and then adds 1 to it, goes back to the top again, and this will loop 100 times, so it'll print this out 100 times. There's a nice video note here which explains this in a little bit more detail. Flow chart here, and some short quiz questions, self-check here. You should check this out. Drag the boxes up or down to form a program that displays the sum of numbers from 1 to 100. Let's see. First of all, we want to put this at the top. And I think we have while. Oh, it's done already. While I is less than 100, add I to the sum and increment I. And when it's all done, it prints out this sum is this value here. All right, what's next? Okay, here's the quiz. Let's go to the first question. Use the variables k and total to write a while loop that computes the sum of the squares of the first 50 numbers from 1 to 50, and puts the result of that sum of squares into a variable called total. And so basically total should be 1 times 1 plus 2 times 2 plus 3 times 3, all the way up to 50 times 50, adding those up. And we only can use k and total. All right, so what I'm going to do is pull up a text editor here, and I'm going to write some code, what I think is code. So basically we are summing. Let's start up by k equals 1 and total equals 1. Let me make this smaller. So let's use k as the counter variable, and we'll start out with k equals 1, and we're going to sum it into total. So let's set total equal to 0, and then we want to loop while k is less than or equal to 50. While it's less than or equal to 50, we want to add to total k, lowercase k, times k. And then after that, we want to increment k. Okay? And so this, I'm going to save this. Save as, I'm going to save it on the desktop. I'm going to call it test.py. And so, let's see. Oops, let's not do that then. Maybe I could put this here. So here we have test.py. Let me throw this away. On the desktop. Where on the desktop is it? Which desktop? I saved it on the desktop, didn't I? Oh, it's saved on my OneDrive desktop. Wrong desktop. Save it on this desktop. Too bad I can't find it. Oh, it's right here. Okay. So let me then find, oh, here it is, and let me find what this address is. I can do that. Properties, where is it? Location, oh, here it is. Copy that. And let me bring up a command line, CMD, and I'm going to do CD paste. So I'm at the desktop, and now I should be able to just run this, python test.py. It's not going to do anything because we aren't outputting anything. So let's change that so we are able to output something. Okay, k is equal to 1. I'm going to, each time, I'm going to do print k equals k, and total equals total. So let's see what this looks like as we run it. So I'm going to run this again, try again. Okay, here we go. So it started out at print k equals 1 total, and each time it's 1 plus 1 is 1, or 1 times 1 is 1, plus 2 times 2 is 5, plus 3 times 3 is 9, 9 plus 5 is 14, 16 plus 14 is 30, and we see it goes all the way up to 50. All right, so we don't want to include this in our solution. So I'm just going to take this here, and this is what we would probably paste in for an answer. So you can try that out and see if it works. All right, what's next? Given that n refers to a positive integer, use a while loop to compute the sum of the cubes of the first n counting number. So now we're doing sum of cubes, and we're first n count. Okay, so we're using n. So we're going to start at 1. We're going to count all the way up to n, and each time we're going to sum the cube of those numbers. So it's going to look something like, start out with that, total of that. This time we need to have a value n. And while k is less than or equal to n, total equals k times k times k. And we increment k. Let's input n equals int input enter n, and let's do the same print thing again. Let's just do k comma total. Save this. See what this runs. See what this does, and let's put in the n of 5, and this is 2 times 2 times 2 is 8, plus 1 is 9. 3 times 3 times 3 is 18. 3 times 3 is 9, times 3 is 27. So 27 plus 9 is 36. Okay, so that looks right. So that's up to 5. So it's something like this. We would not include this, and we would not include this in our answer. So our answer would be something like this. You can try that out and see if it's correct. All right, what's next? In this exercise, we will use the following variables. I will have a low, a high, and a result. And assume that low and high each are associated with an integer and that result refers to 0 to begin with. Write a while loop that adds the integers low up to high and associates the sum with result. So if low is 2 and high is 5, we would want to add up 2 plus 3 plus 4 plus 5 and store that into result. We should not change low and high, and we should just use these 4 variables. All right, well that would, I think, is something like, let's input a low. Low equals input. Now remember, in your solution, you're not going to have these inputs. This is not asking for inputs. It's not asking you to print anything. It's just asking you for the code. I am adding these inputs and so on so I can test the code. So I'm just going to say input low, high equals input high. And then we're going to want to set the result, initialize the result. Okay. And then we want to start out by setting, I is going to be our loop variable. It's going to start out, we're going to start out with I equaling low. And then while I is less than or equal to high, so it's going to go from low to high, we want to add I to result. And we need to increment I plus 1. And I'm going to print I result just to see what it looks like. All right, let's just see what this does. So this should loop starting with low. It should loop until incrementing I each time. It should go until I is greater than high, because as long as I is less than or equal to high, it's going to execute. So let's see what this does. And let's say low is 2, and let's say high is 5. And we see that it starts out at 2, adds 2 plus 3 is 5, 5 plus 4 is 9, 9 plus 5 is 14. And so we see that 2 plus 3 plus 4 plus 5 equals 14. 5, 9, 14. Yep. All right, so I would say that the answer is something like, need that in there, something like this. All right, we might not even need this because it may already be initialized at that, but I'm sure you won't get points off that. All right, what's next? This one is assume there is a variable h. H is already associated with a positive integer value. Write the code necessary to compute the sum of the perfect squares whose value is less than h, starting with 1. Okay, so what we're going to do here is, let's say, gives a nice example. Let's say h is 19. We want to add up we want to start with 1. 1 times 1, 2, 2 times 2, 3 times 3, all the way up until the square is until for all the values where the square is less than 19. So so 1 times 1 is 1, that's less than 19. 2 times 2 is 4, which is less than 19. 3 times 3 is 9, less than 19. 4 times 4 is 16, less than 19. 5 times 5 is 25, so that's greater than 19. So we only want to see 1, 4, 9, and 16 and have it stop there. Now what we're doing is we're adding these up. So we want to output the result when we're done. So we can start with something like, let's see. Let's test this. Let's enter an H. H equals int input H. Do that. So we have H, and so say what compute, associate the sum you compute with the value Q. So I'm going to start out by setting Q equals 0. And then I'm going to do, let's see, I should start out with I. I will be the one, I will be the variable I use to square. So we can start out I equals 1. And what we want to do is while the square I times I, while the square is less than H. So it's going to be 1 times 1 or 2 times 2 or 3 times 3 or 4 times 4 or 5 times 5. When that, as long as that is less than H, then we want to add that square to Q. Q equals Q plus I times I. That works. We can always just do this. So add I times I to Q. And then we need to increment I. All right? And let's print this out. I like to print it out right here so we can see what Q and I are, and then I might, we might not use the next incremented I because it might cause the loop to terminate, but let's just print this part. Print, and I want to print I and Q. I'm going to print I and I times I and Q. So let's see what this looks like. Add an H. Let's just do this first example. Let's do 19. 19. And we get 30 is the final answer. That's the last Q. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And it stops after that. If we do, let's do 26. And we get 5 times 5 in there too. So that looks pretty good. That's probably the right answer. So we would not need this. We would not need this. And this is probably all we would need to enter. All right, what's next? Assume there's a variable H. Write the code necessary to count the number of perfect squares whose value is less than H. So this time we're just counting the number of perfect squares, assign the sum you compute to Q. So we're still summing up. In other words, if H is 19, you would assign 4 because there's 4 of them. There's 4 perfect squares under 19. to count the number of perfect squares whose value is less than h. Okay, so it's the same as, pretty much the same as last time, except for we are instead of adding up the sum, of the I squareds, we are simply counting the loops, counting the number of iterations. So it's you know, something more like this. I think this will work. Can we still use the same variables? It doesn't say, so I think this will work. Let me see. We want to input an h. H equals int input h. And let's print this out right here. Print I times I and q. And let's see what this looks like. And for h, let's do 19 again. And we get stops here, we get 4. If we do 26, we get 5, because there's 1, 2, 3, 4, 5 perfect squares under 26. So we would probably only need to paste in, we don't need this, and we wouldn't need this. So something like that. You can try that if you want. And this last one here, assume there are two variables, k and m, each already associated with a positive integer. This is number 6. So we have k and m, and we assume k is smaller than m. Write the code to compute the number of perfect squares between k and m. So we are gonna, so let's say k is 10 and m is 40. So we want to count the perfect squares in between 10 and 40. Well, 16 is 4 times 4. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49, so that's too far. 3 times 3 is 9, so that's underneath there. So it's these 3, and so there's 3 of them. So we're going to figure out which perfect squares are between these two numbers, k and m, and just count them up. So it would look something like, let's input a k, and let's input an m, and set q to 0, set I to 1. We're going to do this perfect square thing, but we're only going to add 1 to q if I times I is greater than k, and I times I is less than m. Then we increment q. I think I times I is less than m. While I times I is less than m. So we might not even need this here, because we already know I times I is less than m because this part is not gonna execute if I times I is greater than or equal to m. So I don't think I even need this. I'm gonna take that out. So if I times I is greater than k, and it'll be less than m also, then increment. Okay, so let's see what this looks like. I'm printing this out here. Okay, all right, let's see what this looks like. So we're going to input a k, and that can be 10. Input an m and make that 40. And so remember, q is the last one. Q is the last one that's output right here. So we have here, when I times I is equal to 1, q doesn't get incremented. 2 times 2, 3 times 3, 4 times 4 increments q. 5 times 5 increments q. 6 times 6 increments q, and then it quits. So q gets up to 3, which is what the answer is. And 4 times, let's see, that's 6 times 6. What's 7 times 7? It's 49. So if we go up to 50, let's go up to 50. Let's go from 8 to 50. And we would get 9 is in the mix then, because it's greater than 8. And 16 and 25 and 36. And 7 times 7 is 49, so it goes all the way up to 5. All right, anyway, so that's pretty much all we need. We would not need these two because they're already going to be have some value, and we probably don't need this print either. So it's going to look something like that. You can try that out. All right, that's quiz 5.2. Let's see what else is here. Let's take a look at quiz 5.6. Looping design strategies. Let's take a look at some of what the text looks like here. Guessing numbers. Okay, this is interesting game here. Loop design strategies. Controlling a loop with user confirmation and a sentinel value. Okay, what this is about is each time you go through the loop, you ask the user a question, and the question is going to cause the loop to either end or not end. And so that's one way of terminating a loop. The other way, also, like if you're reading in data, okay, well that's the same way. Here's an example where you're going to read in a bunch of integers, and when you're done entering in integers, then enter in a 0, and that's the sentinel value. That's the terminating value. See, so while it's not equal to 0, you do something, but once you enter a 0, then it's going to terminate the loop. And that's a while loop. We have for loops also. So this is a version of a for loop for I in a range. So it's going to start out with initial value, and it's going to add 1 to it, add 1 to it till it gets to an end value. That's one kind of for loop. Like this, is that use the word range? Yes. So for v in the range 4 to 8, that's one way to do a for loop. Here's another way to do a for loop where it's in the range of 3 to 9, but each time you add 2 instead of 1. So it's going to be 3, 5, 7, 9. Except for it's not going to be the 9. If it hits the 9, that's when it quits. So this is actually just going to be 3, 5, and 7 because 9, it'll quit on 9. Here we're going backwards. 5, 4, 3, 2, 1. 5, 4, 3, 2. It's not going to do the 1. It doesn't do the last one. Here's a for loop where we've got a string called S, and for each character in the string, So this is a way to pull out string characters of a string one by one. All right, here's another quiz here. Let's do this quiz. Question 1. Use two variables, k and total, and write a for loop to compute the sum of squares. Oh, looky, another sum of squares. And total it up in total. Only use k and total. So we're doing sum of squares here. So let's start out by we have a k and a total, and we're only, it's all fixed stuff. Okay, so I'm just going to get rid of all this. So we can start out with initialize total, and then we can just do 4k in range we're only going to go up to 50. So range from 1 to 51, because remember it skips the last one. And so we want to go 1 all the way up to and including 50. So that should work. And then, so we're going to total up the sum of squares. So, oops, got to put a colon there. So it's going to be total, add on to total, k times k. And that's really all we got to do. But let's print it out. Let's print this out. Let's print out k. Let's print out total. See what it looks like. Ooh. Okay, so k starts at a 1, k goes all the way to 50, and this is the sum of the squares, I guess. 1 through 5. 1 plus 4 is 5, 5 plus 9 is 14, 14 plus 16 is 30, 30 plus 25 is 55, and it looks pretty good. So what you would do is not include that and paste these 3 lines in. That should do it. All right, what's next? Given a variable n refers to a positive integer value. Okay, so we have an n, and we're going to use 2 other variables, and now we want to write a for loop that does the sum of cubes up to the first n numbers. So let's input an n. N equals int input n. And then we're going to set total equal to 0. And we want to do 4k in the range 1 to n plus 1, because we want to include the n. We don't want to not include the n. And we're doing the cube. All right, let's see what this looks like. N, let's do 5. Okay. 1, 2 times 2 times 2 is 8. So 8 plus 1 is 9. 9 plus 27 is 36. 4 times 4 times 4 is 16 times 4 is 64. So 64 plus 36 is 100. Yeah, this looks pretty good. And it does include 5, because we're going from 1 to 5. So it does include the 5. So you only need whatever part, this part. What's next? Associate the average of the numbers from 1 to n with the variable avg. All right, well, we're going to read in an n, just like this, read in an n. And we got a total here. And when we loop now, we're going to just simply add everything up, add it all up. And when we're done, we want to say AVG equals total divided by n, I guess. Something like that. Now let's print AVG. Let's see what that looks like. All right, let's see what this looks like. And let's say n is 3. So it's 2. So it's 1 plus 2 plus 3 is 6. Divided by 3 is 2. So let's put some print statements. Let's do a print K total. Let's just print that and see what it looks like as it goes. Okay, I'm going to say n is 5. And we get, so here we're at, this is total. 1, 2, 3, 4, 5, these are total. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. And then we take 15 and divide it by 5, and we get 3. That's pretty good. So we don't need this. So it's this, and this, and this, and this. Would probably get you there. Yeah, probably get you there. Okay, what's next? Question 4. Write a complete program that reads 6 numbers and assigns true to a variable called isAscending if the numbers are in ascending order. Otherwise, it's false. And then at the end, we display isAscending. So enter 6 numbers. 4, 6, 8, 10, 11, 12. They're all, this is ascending. It's all ascending. There's nothing, we're never going backwards. So it's true. How about this one? 4, 6, 3 is, this is not ascending. It's close, but it's not, because this one is less than this, so it's not ascending, and it's going to display out false. Same with this one. It's not anything, displays out false. Now, notice that we always enter the 6 numbers no matter what. Like for this one, after we entered the 3rd number, we knew it wasn't ascending anymore, but still we read in the rest of the 6 numbers before we displayed out the false. So that means that we're going to have a for loop, probably, and it's always going to do 6. It's always going to read in 6 numbers, and at the end, as it reads in, it's going to keep track. If the next one is greater than the previous one, it's going to always keep track of that. If it's ever the case that the next one is not greater than the previous one, then that's when it sets isAscending to false. And then it continues reading the remaining 6, if there's any left, and at the end it prints out the value. So let's see what this might look like. Let's start out with something like print. Enter 6 numbers. 6 numbers. It's got to look like this. Enter 6 numbers, and at the end it prints out false. Okay. So we're going to want to let's read in the first number. I'm going to read in the first number. I'm going to call the first number n. N equals int input, and I'm not going to have it display anything on it. I'm just going to have it input. And then I'm going to say, and then I got to read in 5 more times. So I'll use I. I goes from 1 to 5. No, 0 to 5. 0, 1, 2, 3, 4. So I can just put a 5. 0, 1, 2, 3, 4. So for I is going to go 0, 1, 2, 3, 4. That's 5 times. We're going to see if, we're going to read in the next one. So I'm going to call that N1. N1 equals int input. So N1 is the next one. And let's say if N1, if N1, oh no, let's start out by saying is ascending equals true. Let's set out equal to true. Okay, make sure it's a capital T. And if N1 is less than or equal to N, if that's true, then is ascending is false. And then I better set N equal to N1. So it's going to loop through this thing 5 times. Each time it's going to read N1. It's going to see if N1 is less than or equal to N, because if N1 is less than or equal to N, then we know it's not ascending. Because N1 always has to be greater than N for it to be ascending. N1 always has to be greater than N for it to be ascending. If this is not true, if it's not true that N1 is less than or equal to N, then it's, you know what I mean. Okay, so so while if the next one it reads in is less than the previous one it read in, then it's not ascending anymore. Otherwise it is, and so it does this 5 times, and if it makes it all the way to the end, then ascending is still equal to true. If N1 was never less than or equal to N, then this is never executed. So I'm going to, so at the end here we print is ascending. Okay. So let's try this out, see what happens. I spelled something wrong here. Input. Try it again. 1, 2, 3, 4, 5, 6. That should be true. All right, let's try it again. 4, 5, 6, 1, 7, 8 is false. Let's check with these. 4, 6, 3, 10, 11, 12. False. All right, that looks pretty good. So I guess you need the whole thing, because you need to write an entire program to do this. Write a complete program. Okay, well, what's next? Question 5. Assume there is a variable h. Write the code necessary to compute the sum of the first h perfect squares, starting with 1. So in other words, if h is 4, it's going to sum up 1 plus 2 plus 1 plus 4 plus 9 plus 16. All right, so that would look something like this. Let's start out by entering h. H equals int input h. And we're going to sum up these sum of squares. The values sum h q. Oh, q is what I'm going to call. Okay, so that would be q equals 0. And then we're going to do 4. I can use I guess. I in the range of 1 up to h plus 1. Okay. In that range, q, add to q, I times I. And I think that's all we got to do. In fact, I think it's just going to be this here. But let's print this out and see what it looks like. Print I times I, and q. I'm going to print all 3 of those and see what this looks like. Okay, so we want to go, let's do the first 4, and it's 30. The last q that was printed was 30. And so let's do 5, 3, 2. All right, that looks pretty good. So keep in mind, you just need that. You don't need the input and the output because I just put that in there to test it. H already has a value, and you just got to compute Q. Compute Q, you don't have to display anything out. All right, what's next? Question 6. Given a positive integer, assign true if is prime. And the way you know if something is prime is it has no factors other than itself. And the way you know if it has no factors is you divide. Okay, it has no factors other than 1 in itself. So you start with 2, and you go all the way up to the number minus 1. And for each number between 2 and n minus 1, you do n divided by the number. And if it divides evenly, then we know it's not prime. If we try all of them and none of them divide evenly, in other words, you take the mod and the mod is not 0. If we go all the way up and no number divides evenly, then we know that the number is prime. All right, that's kind of a little confusing. Let's try to write some code here and see what that looks like. So first of all, let's read in an n. And then what we're going to do is we got to make, okay, so we're going to do this. Let's, in this little exercise here, let's, okay, so we read in an n, and we set a is prime. Let's set is prime equal to true. Start out by setting is prime equal to true, capital T. And then we're going to do a loop for I in the range of 2 to n, because we want to start at 2 and we want to go up to n minus 1. So remember when we're doing ranges, this number that we put here second, it's going to go all the way up to, but not including that. So in this range, now there's more efficient ways of figuring out if the number is prime or not, but this works, and this is, here we're doing it how the instructions say. In this range there, if n mod I is equal to 0, if that's true, then we found a number that divides evenly into we have found a number that divides evenly into n. So if that's true, then we know that is prime is false. Okay? And yeah, we can, that's all we got to do. Print is prime. All right, so I'm going to do this. Right here, I'm going to print I divides n. Okay? Because it found one that divided n. All right, let's see what this does. This might actually do it for us. Okay, n. So we're going to try all the numbers up. Okay, so we're going to see if, well, let's see if a prime number, what's a prime number? 47 is prime. 47. True. Let's try 48. Oh, look at all these numbers that divide into 48. 2 divides into 48, 3, 4, 6. Okay, that's definitely not prime. What about 127? I think 127 is probably prime, yeah. Okay, what about, well, what's a really big, what is, let's see, let me find a big number. What is, how about 13 times 17? Let's know, that's 13 times 17 is 221. 221. What's another prime number? How about, is 1023 prime? No, it's not. Oh yeah, 3 would divide into 1023. How about 8191? Yeah, that's prime. Okay, anyway, so don't need this, and you don't need this. I think you only need this. All right, so anyway, that's how you figure out if a number is prime, one way. Question 7. An arithmetic progression is a sequence of numbers in which the distance or difference between any two successive numbers is the same. So 1, 3, 5, 7, 9, that's distance is 2. 6, 12, 18, 24, distance is 6, so those are progressions. Given a positive integer distance and a positive integer n, associate the sum, variable sum, with the sum of the elements of the arithmetic expression from 1 to n with distance distance. So for example, we're always going to start at 1. But if it's a distance of 2, for example, it would be 1, 3, 5, 7, 9. Oh, and n is 10, so it goes. This is how high it goes. So from 1 to n and a distance, it does this progression. Okay, so we're talking about. Let's write some code here. Let's input an n, and let's also input a distance. So let's input a distance and input an n. I'm going to call d distance. I'm going to call n the number we go to, and we're going to add up some stuff. Sum equals 0. And so what we want to do is we want to go from 1 to n, but we want to go each time we increment for I in range of 1 to n, but we want to increment by d, the distance. Isn't that convenient? So if n is 10, it's 1, and d is 2, it's going to be 1, 3, 5, 7, 9, like that. And so we do that, and then we're going to sum it up. Sum, add I to it. And that's pretty much all we need to do. Let's print out sum. And I think we're only going to need like this part. But anyway, let's run this and see what it looks like. Run this. It's going to ask for D. Let's do a D of 2. And let's do an N of 10. And we get 25, which is the answer they got here. What about distance of 6 and N of 25? It's 40 because it's going to be 1 plus 7. 1 plus 7 is 8, plus 1, let me just, can I cheat here and pull up a spreadsheet? Equals 1 plus 7 plus, what's 7 plus 6 is 13, plus 6 is 19, no, 13 plus 6 is 19, plus how far did we go? To 25. 19 plus 6 is 25, so it's not going to include 25. So the number is 40. And that's what this is. Okay, fantastic. All right, so you've got given a positive integer distance, an integer n, from 1 to n with distance. Okay, so we need to make sure that this is called distance. Well, you may have to make sure that this is called distance. So, because this is the answer, I think. All right, anyway, so that's quiz 5.6. So let's go back to the assignments here. And what's the last quiz? We did this. Oh, we did that already. Shoots. We did 5.2, 5.6. Now we need to do 5.11. So let's check out that quiz. You should know what a palindrome is. Go through these exercises. And we're going to start out with this one. This first question here. Start with the string, welcome to Python. Write a complete program that reads a string and displays the vowels. So these are the vowels. A, E, A, E, O, U. So so it's going to enter a string, and you enter a string, and it displays out the vowels are E O E O O. E E O E O O. All right, great. Student union. U E capital U I O. All right, let's write a program to count up the vowels, to display out all the vowels. So I'm going to say S equals input, enter a string. And then I'm going to do, I got a loop. I got to loop through all the characters of the string that I entered. So, oh, and I'm going to make a string called vowels. So vowels equals nothing to start out with. And then I'm going to loop through all of the characters of the string. How would I do that? For I in range of just the length of S. So for the range of the length of S, because we're gonna reference each character of S by its subscript. So if this character, if the ith character of S, and I'm not gonna bother. Okay, so I'm just gonna say oh, I'll just do it. Just F lower. I want to do check for uppercase and lowercase at the same time. And but I'm gonna keep. I still have S, so I can refer to whether it's capital or not. But I'm gonna test. I'm gonna set it to lower just so I only need to test for lowercase a instead of also testing for uppercase a. So this is it's equal to A, or A E I O U. A E I O U. U. Read that. If S of I of lower is equal to A or E or I O U, let me do a colon there. I'm gonna do some slash enter slash enter. Okay, so this is the if statement. Let me tab that in. Okay, if that, then I want to append S of I onto vowels. VOWELS plus equals S of I. So that's going to be whether it's upper or lowercase that. But this just tests, this makes it lower to test if it's lowercase a. But if it's an uppercase a, this works, but this, we will get the uppercase a with that. So that's all we got to do. Let's print out the vowels. Print vowels. So this is going to loop for the range, and if it's a vowel, it'll concatenate it onto this vowels variable. So let's see what this does. Now is the time. O-I-E-I-E. Let's try welcome to Python. What about student union? Yep, looks the same. All right, so it would be just something like this. All right, what's next? Given the strings S1 and S2, and they're the same length, create a new string consisting of the first character of S1 followed by the first character of S2, followed by the second character of S1, followed by the second character of S2, and so on. So if we have a word, remember they're the same length. If we have hello and we have world, then we're going to see H from hello, W from world, E from hello, O from world, L from hello, R from world, L from hello, L from world, O from hello, D from world, you see. And that's going to be string S3. All right, let's try to write some code here. So let's enter the two strings, S1 and S2. Enter S1 and enter S2. And I'm going to have a new string called S3, and I'm going to just set that equal to nothing. And so I'm going to do for I in the range length of S1. Doesn't matter, they're both the same. And I'm going to do S1, and then I'm going to do S3, append onto S3, S1 of I plus S2 of I. And then we want to print S3. I think that might be all that simple. Let's see what this looks like. Hello, world. Hello, world. H, W, E, L, L, O, W, O, I, L, D. Okay, hello, world. What about, is that it? A, B, C, D, E. V, W, X, Y, Z. Yeah, it looks like it works. So really, we only need to include, because we don't need this. That's for testing. We do need this, we do need this, we do need this, and we don't need this because that's for testing. Anyway, what's next? Question 3. Given S1 and S2, same length again, create a new string where we take the last character of S1, followed by the last character of S2, followed by second last, followed by second last, and so on. So if we have hello world, we've got the last of hello, the last of world, the second to last of hello, the second last of world, third last of hello, third last of world, fourth last of hello, and then fourth last of world, and then the first of hello and the first of world. So we're just doing the same as we did before, except for we're appending from the rear. So appending from the rear would be something more like let's see. What if we do length of a comma 0 comma -1? Do it. Let's see what this does. This might even work. Let's see. Hello, world. Ugh. String index out of range. I think this should be -1. Let's make this. Let's see what this does. Now we're just enter S1. Hello world. Okay. Is this the same? ODLLL. ODLLREOHW. It's probably right. Okay, that's probably right. Anyway, let's go to the next one. Given the two strings, S1, S2, not necessarily the same length, create a new string of alternating S1 and S2, just like before, except for when we reach the end of one of the strings, no additional characters are added. So in other words, we just forget about the rest of the characters of the one that we don't have any more of. So if we have ABC and then UVWXYZ, it's only going to do A, B, C, and then UVW, and XYZ gets lost. All right, let's see what that would be like. I think what we want to do is, it's this again, except what we're going to go to. The range is going to be, the range is going to be the minimum of the length of S1 and the length of S2. So we've got the minimum here. The minimum of the length of S1 and the length of S2. So it's going to take the smaller one, and that's how big. That's what's the range. That's what the range is going to be, from 0 to that, or to that S1. So this should work, just like that. So it's only going to go up to the smallest one. Methinks. ABC, UVWXYZ. AUB, VCW, AUB, VCW. That could be true. That could be right. What's the last question here? Given the range, given strings S1 and S2 not necessarily the same length, create a new string consisting of the alternating characters, just as before. Once the end of either string is reached, the remainder of the longer string is added to the new string. So if you've got ABC and UVWXYZ, it's going to be the ABC, it's going to be this, but then we're actually going to append on, we're going to add the what's left over. So that's going to be more like, something like this. If LEN S1 is less than LEN S2, and that means S2 is the longer one. So we want to make S3, we want to append onto S3, S2 starting at len S1 to the end. All right. Elif len of S2 is less than len of S1, then we would want to append S1 because S1 is the longer one. So we want to append the rest of the longer one, which is going to be from the length of S2, because S2 is the smaller one, up to the end. That's what that colon with nothing after it, up to the very end. All right, let me see what this does. ABC, UV, WXYZ. Ooh. This, AUBVCW, AUBVCW, and then the XYZ. I think you have enough to now finish all of the quizzes. Let's see, we're all done with the quizzes, right? This one, and this one. So I hope that's enough for you to finish all the quizzes, and in next day or two, maybe tomorrow, I will do the next video on the 6 projects. So thanks for watching.